Hello everyone and welcome to another video. So in this video here I'm going to show my solution for the first two challenges of this TryHackMe room called pwn101. This is not the first time that I'm recording it because I just recorded this first one. I was going to make a video for each of these challenges, and I was planning to make the first video solely for this first challenge, but it is really easy in less than 5 minutes we can solve it. So I decided to make a video for the first two challenges. So yeah, it already has the flags here, but anyway, I'm going to solve it and let's see what happens. So it says it is a beginner level binary exploitation challenge. Here in this getting started page, we see that before making these challenges, we gotta know like C programming language, the basic of assembly, experience with reverse engineering, low-level concepts, Python script, this kind of stuff. I don't have much experience with Python, neither with pwn tools, but let's see what we can do. And then it also says here we got 10 challenges. I think it is 10. Yeah, so 10 challenges and 10 like techniques, or anyway ways that we can exploit a binary. So the first one is buffer overflow, the second one is modifying the value of a variable, and so on and so forth. So I already started the machine, I am already connected to the VPN, and I already downloaded the file. So the first one is this here. It actually gives the hint that it is a good way for us to start with a bunch of A's. So I already downloaded the file and I put it in this folder here, 101. So using strings, we can of course read the strings of the file, and actually it says here it is a 64-bit executable, and it says it is not stripped. So it means that there are a couple of informations that remain in the file after the compilation, such as, for example, the name of the main function, the name of this banner function, setup function. Anyway, so names of functions were preserved here. This means that we can use Ghidra or any other decompiler in order to read the source code, or at least the compilation of the binary, to have an idea of what it does to the system and this kind of stuff. But here at the beginning we got here a reference to libc, and we got some C functions here, and this one here is it is suspicious, like a system function. It is interesting. And here we got some strings, and we got this also suspicious strings here. So probably as we will see in a couple of seconds, it runs system passing the -h as a argument. So if we run here the file, it says, yeah, I'm going to shopping, my mom tells me to buy some things, blah 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 blah, and then it asks us for the required ingredients in order to make this biryani thing that I don't know what it is. But if we just put a lot of A's, just as it says here, like a bunch of A's, it simply spawns us a shell. Yeah, and that's it. That's the challenge. So let me do it remotely. So port 9001, and if we put it here, it says here small git for you, and then we got the a shell here. So you can just cat flag.txt, and here's our flag. So let's just open this file here in Ghidra just to see why does it happen. So how am I supposed to import? Yeah, so here, and now we'll ask for analyze the file. Yes, analyze. Okay, and with Ghidra we can see at the same time we can see the disassembly of the file, of the function or whatever, and also a decompiler. So if we come here into functions, we can see the functions of the file. So we got that banner function that we saw on the strings. We got this setup function with some other functions here, but then we have the main function, and here are the other strings that we saw. So use put s to print this thing here, and it uses get s to receive a value from the user, and then it compares if local c equals to 539 in hex, which is which in decimal is 1337. If it's equal to 1337, it will say, yeah, you lied to me, she did tomato, blah blah blah, and then it exits. Else it will spawn the shell. So this variable local c, it is a hard-coded variable whose value is already 1337. But before the declaration of this variable, before its definition, there is the definition of this other variable here called local48, which is a char of 60 bytes. So since it uses the function gets, which is a like a dangerous functions, I think if we read like the manual of gets, it says it is deprecated, and and it says here never use this function. So it is an insecure function, you shouldn't use it in your applications, but it was used here. And what happens is that this function gets here, I think you can read it, yeah, I cannot make the font bigger, but I think you can read it. But the thing is that this function here is receive an input from the user, and since it is an insecure function, if we pass more bytes than 60, it will overflow the buffer, this 60-byte buffer here. So it will overflow this this buffer, and it will override the values after it. And after this buffer, after this the declaration of this variable, we got this variable local c, whose value is 1337. So we were able to get this to not enter in this if statement here, because once we overwrote this local c value, it is not 1337 anymore, it is something else. In this case here, it is 424242, which is the hex code for the capital A. So when it comes to this if statement here, it will not match, so it will jump for the first for the next instruction, and then it will execute our shell. Okay, so this is the first challenge, really easy. And now let's go to the second one. Okay, let me delete this GDB history here, and oops. Okay. So this second here, if we use file, we can see it is a 64-bit alpha executable as well, not stripped as well. So we can also open it with Ghidra. Import, yeah. So let's open it with Ghidra. It says the file name already exists because I was analyzing it before. Okay, analyze. So the file is being analyzed, and here it just says that the challenge is running on port 9002, so it doesn't gives us any hint. But here we see that we're gonna learn how to modify variables value. So probably this here is a hint, not probably because I already solved this challenge, but this is a hint of what we gotta make, what we gotta do. So in functions here we can see the name of the functions. We got this banner function, setup, same thing, and here we got the main function. So before reading the code, let me just execute it. And it says here, I need bad food to feel dead. Am I right? And then a prompt, we can write something here. And it says, I'm feeling dead because you say I need bad food. Okay. And if we just put a lot of A's here. It doesn't matter, it doesn't change the output. But once we read the source code, we can see here that we got two variables being defined here. So we got this local C variable, which has bad food as its value, and this local 10 variable, which has this minus blah 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 whatever as its value. Okay, so it uses printf, and it prints I need, and here is used this string format thing to print this bad food. So I need bad food to fill that. So it is this thing here that is being printed, and then it says, am I right? What is the am I right? Okay, so we use this scanf, probably this am I right is in this location here, but it used this scanf and put the result in this local 78 variable, which here is undefined, but it's probably a char with a size of 104. So if we send more than 104 bytes, the same thing will happen. So here, getting back to the first challenge, here we got a char with 60 bytes of length, and after we send 60 bytes, the next bytes overwrote this local C variable value. So the same thing will happen here. We got 104 bytes, and then after it we got the definition of these two variables here. So local 10, which is both of these variables here have its value hard-coded here. So if we overflow this buffer here, we will be able to change the values of these two variables here. But okay, so why would it be useful? Because here, after this, after the program receiving our input here, after this scanf function, it uses this if statement here. So it checks if the local C variable equals to coffee and the local 10 variable value equals to code, then it will print and then drop our shell. But the local C variable value is bad food, and the local 10 is this thing here. So we're gonna overflow this buffer here, and then after 104 bytes we'll be able to change the values of these two variables in order to make this if statement here valid. Okay, so yeah, so let's open this file on GDB. And let's see. I think we can do like info functions. Yeah, so I'm going to disassembly the main function. So this is the main function here, and I'm going to put a breakpoint right after this scanf here, so before this if statement. So the scanf is here, and right here is the if statement. It is using a compare, and it is comparing the offset RBP -4, which is a point in a stack, with the value coffee. And if it's not equal, so here we got a jump if not equal. If it's not equal to coffee, it will jump to 992, which is this here, which probably will print that thing like, yeah, I'm filling that because it's blah blah blah, and then we will exit the program. So it will compare this, and if it's not equal, it will terminate the program. But if it's equal, then it will compare the offset RBP -8 with code, and then if it's okay, it will call the system function. So we gotta make sure that we can change the value of RBP -4 and RBP -8. So RBP -4 need to be coffee, and RBP -8 need to be code. And since we saw here that we got this 104 bytes buffer, we can, for example, we can run let me see if I can use Python here. So Python minus C, and then here let me use Python 3 minus C, and then I will print 104 A's, right? And then I will print 4 B's and 4 C's. Let me run it. Okay, yeah, I just forgot to put the breakpoint. So let me put the breakpoint here. So I think it is BP, and then this, no, I think it is break. Yeah. So I put the breakpoint right after the scanf function. And now let's run it. And I pass in here 104 A's in order to fill completely this buffer, and then 8 bytes after it. Okay, so we hit the breakpoint, and now it is comparing the RBP minus 4 with this C0FF33. So let's take a look at this RBP minus 4. So we can use like this X here and use the RBP minus 4. So in RBP minus 4 we got 43434343, which is the hex value of C, which makes sense because we send a bunch of C's here. It means that if we take a look at RBP minus 8, which is the second comparison that it makes here, it will have, let me see here, it will have 42 4 times, because 42 is the hex value for B. So if you take a look at this, we got 42. Yeah. So now what we need to do is to change these values here. So instead of 43, 43, 43, 43, which is this C's here. So the 43 in the 43 was in the RBP minus 4, and the RBP minus 4 needs to be C0FF33. So we just gotta put here C0FF33. Since this is in the little engine, we gotta reverse the order of the bytes here. So instead of C0FF33, we got 33FFC0. Okay. Now let me just put these to format into a hex string, a hex bytes, and then I'll put a no bytes at the end just for padding reason. Let's run it again, and now let's take a look at the RBP minus 4. Yeah, so there's something wrong here. I'm not quite sure. Oh yeah, I think I should put this no byte at the beginning because it will reverse and then it will be at the end. So let's take a look. Let me see. Okay, I'll not use Python for this because I just remembered that I've done a bunch of buffer overflow challenges, and every time I use Python, something related to the encoding just breaks the code. So I'm going to just use Python here. So let me just copy this here, just to print this bunch of A's here. And instead of Python, I'm going to use the echo. So echo-e to use this extended notation for hex strings. So we have here 104 A's. Let me close this terminal here. We've got 104 A's, 4 B's, and now this here. I think it should not be in quotes. Yeah, let's see what happened then. Let's take a look at RBP minus 4, and now we have here coffee, but then the no bytes are at the end. Let me change the order here. put it here. Yes. Yeah, so now we have this coffee at the right place. And now if we use ni for next instruction, it will compare the RBP minus 4 with this coffee thing here, and then it will jump if it's not equal. But since it is equal, as we just saw here, it will jump to the next instruction which is this compare thing here. So next instruction, it will compare, it will not jump, and now we will compare the RBP minus 8, which is just a bunch of B's. So it is comparing the RBP minus 8 with this C0D3. So we just need to come here, and instead of BB, we can put C0D3, but in the reversed order. So it is D3 and C0. And since we put this null byte here at the end, we gotta do the same here. So we gotta need 2 null bytes here to fulfill the 4 bytes for this register here. Let's go. And it is 4 bytes because it is a 64-bit executable. Okay. And now if we take a look at the RBP minus 8, it says COD3. So let's make next instruction. It will not jump because the validation now is correct. Okay. Now it is comparing RBP minus 8 with code. It will also not jump. And that's it. So if we just continue here, it will print, yes, I need coffee to code, blah, blah, blah. And then we got our shell. Okay. So this here is our payload. Let me just copy here. Okay. Yeah, so if we run it with this pound thing here, it says, yeah, I need coffee to code, but we didn't get the shell, right? But if we use like, I think it's strace, see the system calls. Let me see here. I thought we will be able to see the calling of the binsh process, but for some reason it is not showing here. Oh, okay, so probably we gotta let me see if no, okay, I think we gotta use that old cat trick like this. Yeah, so the thing here is that since it creates another process for binsh, once we run this, it will just send this to the executable. It will not create like a channel between our terminal and this new process. So the trick that we can do here is to put this whole thing inside parentheses, and then after shellcode, we put, which is not exactly a shellcode, but anyway, after it we just put a cat, because the thing with the cat is that everything that we type into the std_in will be reflected to the std_out, and it stays here, it will not close. So we can use this to maintain a channel, quote unquote, open between our std_in and the std_in of the binsh process. Okay. So since we do this, we now have a shell here. Oops, where am I? Yep. And now if we get this IP address here, we can just pipe it to netcat. The port here is 9002. Oops. And we got the shell. And here is the flag.txt. So that's it. I think this is enough for this video. I don't know if I'm going to record the other challenges, probably, but I cannot be certain. I don't know if I will have time for this and desire to. But that's it. I hope it was useful. Any questions you can put in the comments below, and I'll see you in the next video.